We're here at the Paris Air Show with Bob Saia from Pratt & Whitney. Bob, thanks for taking the time with us this morning. The geared turbofan is obviously a hot topic. You've got 5 development programs underway. But where do you see technology moving forward with the geared turbofan program down the road to get that extra 10 to 20% beyond where we are today to continue to improve the engine and particularly a focus on its technologies?
Well, the base geared turbofan architecture has really performed well for us. By us introducing this gear, it's really opened up several areas for us to launch this technology path from our base. And our overall objective is to improve the engine 1% per year in terms of fuel efficiency improvement, and continue to extend or improve cost of ownership by extending service intervals with improved materials and longer time on wings, just to help share that overhaul cost over more operational flight hours. So there's 2 basic elements. The first element is continuing to develop the geared architecture. Instead of going from a gear ratio of 1 to 3, so 1 revolution of the fan to 3 revolutions of the turbine that powers it, we're looking at going in the order of 4 to 4.5. And what that allows us to do is to make that whole fan stream significantly more efficient in making power, which results in fuel efficiency, or lowering noise, which is just really good for the overall airport community noise. And that's just fundamental from an architecture. And that architectural change would really be done with a new airplane application. It's not something that could be retrofit easily in one of these 5 programs that we've had. The more important element is what we're doing to fundamentals to the engine to really improve what we call the core or the thermal efficiency of the engine. And it has to do with aerodynamic improvements, physically in terms of making each component more efficient as it does its work, raising pressure or drawing power. Second element is the materials that we use, and the materials can really be lightweight materials to take weight of the engine down, or materials that have more temperature capability. In the turbines, for instance, of our GTF, the turbine materials operate at gas temperatures that are above the melting condition of the material. So what we have been doing as part of our, I'll call it first generation GTF, is really working on managing the amount of cooling flow and using that reduction in cooling flow for fuel efficiency. So for instance, if we take our engine, the PW1100G for the A320neo family, we have reduced cooling flow by 20% relative to our conventional design, conventional turbine airfoil and materials design. That 20% reduction has resulted in a very significant improvement in fuel efficiency. So while we call it a geared turbofan, those technologies are a key enabler for the successes we've had. Now, as we've looked at the technology development that we've had, primarily in our military sector with our F-119 and F-135 engines, we have developed significant capability in turbine materials, cooling characteristics of those turbine airfoils, and the coatings that we use to buffer that material from the gas path there. And that is really our attention as we look at materials development in our next phase of geared turbofan products. As we develop these technologies, there's a twofold approach. One approach is for us to increase or improve fuel efficiency or increase fuel efficiency by 1% per year. It's a combination of both architecture as well as aerodynamic and materials technology. We'd like 50% of that to be capable of being retrofit in the early GTF models. So come 7 or 8 years from now, as engines are coming into the overhaul facility to be upgraded, these new technologies would be available in the parts that those engines are operating today, that would result in improved time on wing or lower fuel use because of the inherent benefit of the material and the coolant. So it's a combination of architecture, turbine materials or lightweight materials, and then the third element that we're looking at is going to higher operating pressures. So today, If you look at an engine like a CFM or a V2500, the overall pressure from the air entering the engine to where the fuel is inserted goes up about 35 to 1. On the case of our geared turbofans, we're in the 45 to 50 regime. Our next generation of engines now will go 60 and above. So continue to put more overall pressure rise, which allows the engine to be more efficient as it's making that power, resulting in a lower fuel efficiency, higher fuel efficiency, or lower fuel used, and lower emissions.
What's the trade-off between pressure ratio and maintenance cost in an engine and achieving the thermal efficiency for that overall pressure ratio by increasing temperatures in the engine? And how important are these advanced materials in that process, Bob?
Yeah, the real trade is metal temperature. So as we create materials that have more temperature capability, or these ceramics that enable us to basically blanket or cover the material to buffer it from the real gas path temperature, as long as metal temperature stays constant, there's no decrement to our maintenance costs or time on wing intervals going to elevated temperatures and pressures. That's the trick. The trick is holding metal temperatures. What we've done, as I said in our first generation, is we've used less air, less cooling air to bring that fuel efficiency. As we go to higher temperatures and higher pressures, we will raise that cooling flow, but the benefit of the higher temperatures and the higher pressures will overcompensate in terms of fuel efficiency relative to the small change in cooling air that we may have to apply to those parts.
So it's a careful optimization trade-off that you do between maintenance cost and fuel efficiency to deliver overall value to your customers.
Correct. And fuel efficiency is always the most dominant player, right? So fuel costs today are 40 to 50% of an airline's direct operating cost. So fuel is always the biggest nugget, or the biggest knob. I use the word knob to turn. And then maintenance costs come second. But we need to work both, because both have a significant influence on engine operating costs of the airline.
Thank you, Bob. We appreciate this view into the future of the Geared Turbofan program.
My pleasure.